Okay, hello everyone. I'm here with James Fodor and Robin Collins. James is a PhD student in neuroscience, and Robin is a. I should have looked into these things ahead of time. You're a professor of philosophy at Messiah State University.
No, just Messiah University. It's private.
Okay.
University.
Yeah. So, and we're going to be talking about fine tuning today. Whether it's a good argument. Robin thinks, it's a very convincing argument for God. James disagrees. So, yeah, anything to add for either of you? Did I miss anything? James has a YouTube channel. It's linked below. Robin has a bunch of papers that are also linked below.
Oh, thanks for inviting me, Matt. I hope it's a good discussion.
Yep, thanks for inviting me too.
Yeah. So I guess maybe. Yeah, so maybe Robin, you should start by just laying out like what the fine-tuning argument is.
Like in 5 minutes, do you want like 5 minutes?
Yeah,
like
sounds good.
Okay, so the fine-tuning argument is an argument for the existence of God or something like God. Unfortunately, we just got a train that's coming by. So you probably can hear that, but I'll continue talking. So it's an argument for the existence of God from the fact that called fine-tuning, that the fundamental structure of the universe has to be just like right for life to occur. And particularly the relevant kind of life here is what I call embodied conscious agents, which are agents that can interact with each other and make decisions based on what they consider moral criteria. The fine-tuning falls into 3 categories. There's the fine-tuning, which you could call the laws of physics. There needs to be the right set of laws of nature, by which I mean the mathematical form of the laws. For example, Newton's law of gravity has the mathematical form, force equals mass. When you have 2 pairs of masses, the force between the 2 pairs is equal to the mass of the one pair times the mass of the other, divided by the distance between them squared, times a number called the gravitational constant G. That's the mathematical form of the laws, and there's ones that dictate how electrons interact with each other, how light works, so on and so forth. There's a whole bunch of basic laws, both some given by cosmology and some the most basic ones in the micro-physical realm are given by the standard model of physics. So then, besides those basic mathematical forms of the laws, there is what is known as the constants of physics. I think a better name is the fundamental parameters of physics. There are these numbers, like the gravitational constant G is a number that I just mentioned in that law called the gravitational constant. It's a fundamental parameter. Other fundamental parameters would be the mass of the electron or the mass of the quarks that compose the electrons. They're the parameters that are the numbers that are so fundamental they can't be derived from any other set of deeper numbers. And those seem to have to be just right in enormously degree of precision for life to occur, for life of this relevant kind. And I should say what I mean by life here is the embodied conscious agents. And I take a fundamental condition for such life, which really the fine-tuning hinges upon, is the existence of complex reproducible complex structures that can reproduce. And then there's the fine-tuning of the initial distribution of mass energy in the world, and that has the most enormous degree of precision of any of them. The degree of precision is quite astounding, and that's what's made it so impressive for people. The most focused on type of fine-tuning has been the parameters of physics, because you can look at then what happens if you change those parameters, what kind of universe you would get. So that's the basic data. And then the argument moves from that data to the existence of God. And there's different formulations of the argument. Some do it as inference, the best explanation. I prefer a likelihood formulation that claims that the fine-tuning evidence strongly confirms the existence of God over what I call the naturalistic single universe hypothesis, and then and then for separate reasons, the naturalistic multi-universe hypothesis. So, and the argument there, I cash it out in a Bayesian way that the reason the evidence confirms the one over the other is it's a lot more likely under the theistic hypothesis, that these parameters, for instance, or the laws would be what they are, life permitting, than if naturalism was true. So that's the basic fine-tuning argument as I lay it out.
Yeah, cool. So James, do you want to, I guess you could give a few minute talk, or we could just go into open discussion where you could present your first objection. Either one's fine.
It might be better to just go straight into discussion. I don't know how much you want to lead, Matthew, if there's particular avenues you think we should discuss, or...
No, I mean, I'm happy leaving it mostly.
All right, that's fine. So, thanks, Robin. Maybe I'll just stop asking some questions or highlighting some areas where I personally haven't found the argument convincing, and see where we can go. So, I think one of the major issues with the argument is establishing what the conditions are for the existence of, as you term, embodied conscious agents. So that the idea is that, well, you didn't actually say this, but the idea is that an embodied conscious agent is supposed to be something that God would have a reason to create, right? And so the constants of the laws of physics are fine-tuned to enable that type of life to exist. That's by God to enable that type of life to exist. That's the idea, right?
Yeah, that's the idea. I actually think it's highly vulnerable embodied conscious agents to each other and their environment, and that will encompass then the problem of evil. But that's a later development that I've done with the argument.
Okay,
so I think God would have a reason for creating that kind of being. You can at least a glimpse of reason. I would say we can glimpse a reason.
Yeah, well, I'd like to talk about that a bit more maybe in a moment, but I just wanted to clarify. So that's the basis on which God has fine-tuned the universe. So my question is then, how do we link the evidence we have from science, which doesn't, in my view, tell us much about what the conditions are for the existence of embodied conscious agents, to the argument that that's what God fine-tuned the universe for? That is, the fine-tuning evidence, as I read it, tells us that if the constants were different, then we wouldn't have galaxy formation, stable stars, we wouldn't have chemical elements, these sorts of things, right? Now, it's absolutely true that we need those for life as we know it, right, in our universe. So I accept that fine-tuning evidence with respect to that, right, as in that if you change the constants, then our form of life is impossible. But that isn't the same as saying that no form of conscious embodied agents would be possible. And it seems to me that we don't really have much of an ability to know what the conditions are with respect to the constants for that will be necessary for the existence of embodied conscious agents. So how do you see making that connection?
Well, I see that there has to be matter that can that can stick together and gain some kind of complexity. So it doesn't have to be carbon-based complexity, but if you're embodied and conscious and you're interacting with other people or other things, other body conscious agents, you have to be able to move the matter. The matter has to be connected together in some way. So it's really a question of the conditions for getting, really at the most basic level, it's conditions for getting any kind of significant complexity. So you can see this in some of the arguments, like if the strong force were much weaker, you couldn't have protons binding together. So you couldn't have higher level atoms. And if you didn't have higher level atoms, all you'd have is hydrogen gas. And hydrogen gas, unlike what you see in Star Trek, though I love Star Trek, you cannot get in embodied conscious agent, you can't get a hydrogen gas being that can interact like that with other beings. You just can't get the stable complexity. or if the cosmological constant or the dark energy density were much larger on the range of possible values, then no galaxies would form. And once again, you wouldn't even have planets, you wouldn't have matter sticking together, basically. You just have matter distributed throughout space. And in fact, the distribution would get thinner and thinner. So I don't see how in just thin space without much of anything, maybe a few atoms per cubic meter, or you could get any embodied conscious agents.
Right. Well, let's. I think those are two good examples to talk about. So the first one about, let's say that no high level chemistry could exist. I've never found these sorts of arguments very convincing, and maybe we can sort of discuss why that is. But I can accept that, for example, if the strong force were weaker, then we wouldn't have binding of more complex elements, right? But then where I see the leap is in being told, well, then all that would exist is hydrogen, and then there would be no possibility of complex interactions, because I don't really see how we know what a universe would look like if many of the constants were different. We can say, I think, with reasonable certainty that we wouldn't have the types of interactions we have now. That's one thing. But then to say what there would be or what there wouldn't be, like as in, well, there wouldn't be anything else, to me is really a big extrapolation. One way that I think about this is that it seems that there's a gap between the way that we approach understanding our own universe and the way that we approach understanding what would be possible in hypothetical universes with different constants. So, for example, in our universe, we study the properties under which galaxies can form, stars can form, heavy elements form, and give rise to biochemistry and all that sort of stuff, right? But we do that from the point of view of knowing that these things exist. What we don't do is start from the basic, like Lagrangian formulation of the standard model, and then infer from first principles everything that would follow from that. We have no ability to do that. We can't even solve for the properties of basic simple molecules from using basic principles in quantum chemistry, let alone the actual Lagrangian of the standard model, right? So the point is that we're standing from an epistemically privileged position with respect to our universe and what's possible within it. And so we can see, oh, well, these complex interactions happen as a result of, very complicated emergent phenomena. But we're not in the position to do that with respect to other possible universes, obviously, because they don't exist. And all we have is just the mathematical formulations. And so I'm very skeptical about inferences that say, oh, well, there wouldn't be any higher level structure possible, because I just don't see how we have access to that information.
Well, some implications of changing things are complex, and so then you're right. We can't solve like the Lagrangian for the standard model, and we don't know all the complex implications. That part is true, but other things are really straightforward. Like we can't solve the three-body problem, or if there's a million masses interacting, we don't know what happens. We can't solve that problem, even on a computer with very much accuracy. But we would know what would happen if you decrease the gravitational constant down to zero. There wouldn't be anything to be attracting anything else, and so we know straightforwardly we don't need to go through a complex analysis to know that there wouldn't be any planets. We wouldn't be setting on this planet if there wasn't any gravitational force left.
Yeah, of course. So what that tells you is that there wouldn't be any gravitationally bound objects in a universe without gravity. For me, that's all that it tells you. I don't accept that we can make inferences that therefore all types of structure that could potentially form the basis for embodied conscious agents therefore would be impossible, especially when we consider varying multiple parameters at once, because the argument to me seems to rely on the idea that across the sort of volume of parameter space, the vast majority of combinations of those parameters would not be life permitting. But then if that argument is to go forward, it means that we have to explore the entire dimensionality of that space and not just say that if one parameter was set to zero. Perhaps if one parameter was set to zero or very high values or something, then we might be able to make a conclusion. But what we need to be able to say is what happens in a sort of representative sample of the entire dimensionality of the space. And that's where I'm especially skeptical that we have any ability to do that.
Well, I don't think that's right that we have to do that, because like I said, there's straightforward implications. Like if the cosmological constant were a lot larger, you just would have matter distributed everywhere. So if you have, let's say, one atom or one proton per cubic meter, there's only going to be little teeny bit of gravitational attraction. We know there's no strong force attraction. That forces out. There's not going to be any weak force attraction. And it's going to continue expanding. There's just not much room for things that there's a kind of minimal requirement. They kind of got to stick together to get complexity. And that necessary condition is not met because that necessary condition requires that certain parameters fall within, regardless of what the other values of the parameters are, within a narrow range of parameter space.
Well, yeah. So let's talk about that example then, the example of the dark energy one, because I mean, I'm especially skeptical about inferences to dark energy because of how poorly it's understood. But granted, from what we understand about it at the moment, that's right. So if dark energy, it was stronger, then the expansion of the universe would be greatly more rapid, and then at this stage in the universe's evolution, there would be almost no interactions between anything, as far as we know. But again, this seems to me to presuppose that there's sort of a appropriate temporal scale to how quickly life has to emerge or develop in. Obviously, on timescales of billions of years, if you have a much higher much higher strength of dark energy, then you're not going to see much interactions after that time. But that doesn't really tell us much about what happens in the very early universe and what might be possible in those periods of times. So it seems to me that we're privileging a certain temporal and spatial scale when we're making these hypothetical changes to the parameters about what scales life has to exist on.
Well, there's not stable reproducible complexity because we know all there is just plasma at the very early stages.
Well, in our universe, yeah. But what about hypothetical possible universes with different constants? I don't think we do know what would exist at those. And would a form of embodied conscious agency be possible in such conditions? I don't think.
Well, it would be even if the other constants were different, and there would have to be constants governing the forces between matter, even if they were different. It would be extremely hot, and the heat would not allow the bonding together. I mean, you'd have to have bonding together, I guess, electrochemical bonding. But even apart from that, let's suppose that's not correct. Well, I don't think you have to look over the entire parameter space. When you do a probabilistic analysis, you throw some stuff back in your background information, and you conditionalize on that. And any kind of probabilistic analysis does that. Like if you're doing, in a murder case and you're looking at the fingerprint evidence, where you have a lot of things in the background about the, techniques you're using for looking at the fingerprint. So all these other values of the constants, we can just stick them into the background. We can take those as given. And then we're looking at this evidence, the particular evidence of what happens when we vary these particular values. And what we notice is which I call that the epistemically illuminated region, the region of which we can make those kind of determinations. And in that region, we see a very, very small part of that region, a teeny part of that region allows for life. And so an analogy I use is if you had like a huge dartboard that extended, you don't know how far, and you have this area, there's a big spotlight on this area. So that's the epistemically illuminated region. That's what you can see. And then this dart comes in, and there's a teeny, teeny, teeny bullseye in the center. And the dart comes in and hits that bullseye. Now, you conclude, I think the natural conclusion is between two hypotheses, it was randomly thrown, just like some machine randomly threw it, or it was aimed by an expert dart thrower. I think it would strongly confirm the expert dart thrower hypothesis, because what you would do is you'd throw into the background, there's a dart, the background information, the evidence is that it hit the bullseye. Then in the background there's this illuminated region, and the dart hit somewhere in the region. Then what's the probability of it hitting that bullseye under the two different hypotheses, and it's much larger under the one than the other. You don't have to determine what the probability, whether there could be zillions of other bullseyes. We don't know, but that doesn't matter.
Well, so it seems to me that it does matter depending on what the question is. So is the question, what's the probability that the dart hit that bullseye, or is it the probability that the dart hit a bullseye?
Yeah, but it's really that it hit that bullseye, because we don't know the number of other bullseyes, and that's all you need for confirmation, because you're confirming against background information. You always do that. Like in a murder case, you accept all kinds of things about there's a gun here. Well, what's the probability there even being a gun that was available to be used? Well, I don't know. So you don't look at that. There was a gun and there was a bullet. You don't look at what's the probability that a gun existed in this city. I have no idea. And you don't need to know that. You can just assume that's part of your background information. And we always do that, because if we couldn't do it, if we had to include if we had to have as our evidence everything, we'd never be able to get any kind of probabilistic reasoning off the ground.
Well, I don't really agree with that. It does seem to me that the probability, let's take that murder case as an example. It seems that the probability that the perpetrator had access to a gun is absolutely relevant when assessing probability. For example, if the crime happened in Japan versus the United States, where availability of guns is dramatically different, that would, I think, reasonably affect the judges and jurors' estimation of the probabilities of, certain witness testimony or whatever it was. I don't really see how you can just decide that that's not relevant.
The perpetrator having an access to a gun, but there being a gun is what I was saying, that there being a gun being used. We take that as given there was a gun being used. Now, the perpetrator having an access would be relevant. Anything that's relevant, which the probability is, you can't throw into the background without begging a question to the other side. Anything that would have a higher probability under the one hypothesis than another. But you can throw anything which you don't know what the probability is, because there's all kinds of things particular details we don't know what the probability is. Let's suppose the gun had various sorts of detailed scratch marks. Well, normally, you might know that about the gun, but you don't consider it relevant, because you don't see why those scratch marks would favor the defendant killing the person versus somebody else.
Yeah, right. But that's just not relevant.
But if you knew the defendant was he was suspected serial killer who made those kind of scratch marks, then it would suddenly become relevant, and you wouldn't be sticking it in the background. Now, in the case of the dart, you don't know anything about the probability of these other cases. So what you don't know neither favors the non-dart thrower hypothesis versus the random dart thrower hypothesis. It could be even more sparse, the region outside that you can't see. You don't know. And so what you have to do is you have to go on the evidence you have. It's very much like you make predictions of a theory. There's all kinds of predictions the theories make that you don't have the ability to test. So when a theory gets confirmed, like evolution or some other theory, you go on the predictions you can test. That's what matters for evidence. Somebody could say, well, you haven't tested all the predictions. Well, a lot of them we can't test.
Yeah, well, I accept that you don't have to test everything and the evidence doesn't have to be perfect. I'm not arguing that. But I don't agree with your claim that if we don't have one, I don't agree to say that if we don't have a reason to think, if we don't have a clear reason to think that an unknown factor or piece of evidence favors one side versus the other, then it's appropriately ignored. I think that that's not how we do inference. So, for example, if I am trying to answer a question and conduct a survey, right? And I select my sample in a way that is demonstrably not representative of the population, right? So we know that the sample is not representative, but we don't know whether this is going to bias the results in any particular direction. Like we suspect that it may well, right? Because we know that it's a non-representative sample, but we don't know which direction or really the magnitude. Now, it seems that you would be telling me that, well, we should just ignore that issue and interpret the evidence on face value. But that seems entirely wrong to me. We should downweight our confidence in that results of that survey on the basis that the results are probably not representative of the underlying population, even if we're not sure which direction they're biased in.
Well, we might downweight it. We'd still take that seriously, because if it turned out to be super small, let's say the probability, we would think, well, it would be very unlikely that would be biased to make it so small. So the bias might make it somewhat small, but super small, it's not going to. So if we started saying that, then the probability just gets kicked back to the situation of how biased it is. I want to ask you, what would you do with the dartboard case that I gave, the epistemically illuminated region?
Yeah.
Would you think that that's supported? And let's say, would you think it supported that the dart was aimed? If it was, let's say, 1/1000th of the entire region, it was really, really small part of that region.
Well,
and you knew the aimer was really, really good, could get it into that small of a region. You'd have to know something like that.
Sure. Well, yes, with regard to the dartboard analogy, my position is that the finding the dart in the single bullseye that we can observe in the epistemically illuminated region is not necessarily surprising if we hypothesize that there are many other that there is a large number of bullseyes across the whole space. And it seems to me that what we would need to postulate is that the space of what are we talking about? The dartboard space of bullseyes relative to non-bullseyes is not sort of simply distributed, right? So, and I think this is very reasonable to postulate with respect to regions of parameter space that could support complex structure, because we observe this all the time in biology, that if you're looking at, for example, or in chemistry as well, if you're looking at energy landscapes where a particular structure is stable, there'll be a particular conformation, excuse me, of bonds that support that structure. And then if you change one of them slightly, the energy is completely disfavorable and that structure couldn't exist. So you might naively assume, oh, well, it can only exist if there is this exact conformation of bonds. But in fact, there are other possible conformation of bonds that may support a functionally similar structure. It's just that they're not simply connected to each other. So they exist in a sort of very complex landscape.
Well,
that's something like what I would expect to see. And therefore, it's actually what you would expect to see then is sort of bullseyes surrounded by non-bullseyes regions, and then there'd be this sort of complex structure.
If there was all these other non-bullseye regions there, and in order for that, and if let's say they dominated the landscape, they were very close together, okay? Because if they weren't close together, if all of them had a huge space around them, right, of no bullseyes, then it wouldn't matter. It would still be very unlikely for the dart to hit a bullseye. So what you have to hypothesize is outside your epistemically illuminated region, it's jam-packed, high-density bullseyes, okay, in order for that to work. Because otherwise, if it's not high-density bullseyes, very low-density, as it is within that illuminated region, then you're going to have the same improbability.
Yes, I accept that. But the thing is that the space we're talking about is very highly dimensional.
Yeah, okay, but just let me, if it's jam-packed, though, then you've just shifted the unlikelihood. Now if you have a jam-packed hypothesis versus non-jam-packed hypothesis, it's very unlikely under the jam-packed hypothesis versus the non-jam-packed hypothesis is going to hit a region which only has a bullseye surrounded by a huge blank area. Then those are very, very rare. So now that hypothesis is strongly disconfirmed.
Yeah, right. But that's what I was saying, because so it's misleading if we think of this in two dimensions, because if you show a bullseye surrounded by a circle of non-bullseyes, then yeah, I mean, if the that means that if the dart hits the bullseye, then it's surrounded by a sort of simply connected region of non-bullseyes. But that's just not true in very high dimensional space. You can have, and this is what I was talking about with varying multiple constants, right? You can have instances where varying any single constant leads you to large regions where, well, region is a problematic term because of the difference in volumes, but varying one parameter at a time, you could have like a line where, oh yes, there's no possibility of complexity here, let's say, but that doesn't tell you actually about what the whole volume looks like in many dimensions, because it could be extremely complex.
Well, then it would still be unlikely you would find that. Even, I don't think the complexity is going to help. Let's just go to 3 dimensions. I can't visualize. I'm sorry.
No, you can't visualize this. This is part of the issue, right? It's very difficult to
but let's
visualize this.
Let's suppose. I mean, I went from 1 dimensions. It clearly holds in 2 dimensions, and it clearly is going to hold. But in 1 dimension,
it doesn't hold, right? So you can have a space that's not simply connected, and so the overall like hypervolume could be packed with
2 dimensions. 2 dimensions. Does it hold in 2? It holds in 1 dimension. This argument. It does hold in 2 dimensions. Well, it seems to, right? The analogy was done in 2 dimensions, and it clearly holds in 1 dimension. So let's go to 3 dimensions.
It doesn't necessarily hold in 2 dimensions if you view it in the right way. So let me you can visualize it in 2 dimensions. Maybe this will help, right? So you could have a line along the x-axis, let's say, where if you move along the x-axis, you find that there are no bullseyes. So there's bullseye at the origin, but there's nothing else along the x-axis, right? And so if you're just considering the x-axis, you might say, wow, there's no bullseyes here except for at the origin. But if you move in the y-axis, there could be bullseyes not even everywhere, but they could be offset in like a complex arrangement, right? So that there's many spots that are bullseyes and many that aren't. So the overall area that has bullseyes, if you consider both dimensions, could actually be large. But it still could be the case that in any line there could be large segments that had long lines without bullseyes, and this becomes the possibilities for that multiply the more dimensions you have, because the space becomes more complicated. And that's the sort of complex, sort of fractal-like structure that I personally would expect to see, given the types of emergent complexity that we're talking about, because it's the type of thing we see in chemistry and biology.
So if you did an integration over that, let's suppose you integrated, and usually integrations are done, so you take a single line differential thickness, right, of a single line, and the proportion of that crosses a bullseye, okay? And so if bullseyes were really common, if it was common in the space, then in the typical differential element, the differential in the y direction, you're doing a differential in the y direction. If they were like, if bullseye was really common, then it would be a very rare one that, let's say they were like 90% real common bullseye. So 90% of the time it crossed. So on this differential dy, a 90% of that dy as you move across here, across the bullseye, that would be the typical one. If you ran across one that was only 1% across the bullseye, well, that would have to be rare, because if that were the case, and then you integrated that over all the dy's, you would get, if it wasn't rare, it was the typical one, then you would get only 1% of the space would be crossing bullseyes, contrary to hypothesis. So your typical one is still going to be in the x direction over the x-axis with dy width. It's still going to be very rare it would have a bullseye on it that would cross a bullseye.
Yeah, well, that's certainly, yeah. So the two-dimensional.
We're just doing an integration argument over the whole space.
Well, yeah, but that's sort of precisely the difficulty, is that I can sort of articulate it in the two-dimensional space, but I don't think it really articulates the point very well, because really what we should be considering is the entire dimensional space. And from my point of view, the prediction, well, not prediction exactly, the statement is something like that: if we considered the full dimensionality of all of the constants, what we would expect is that our actual universe has the like the typical amount of surrounding life permitting and non-life permitting
Right.
space of constants. That's what
we
my view would entail, right? And
right.
I don't think we can know that because we don't have the ability. Well, we sort of talked about exotic forms of life, but now we're also just talking about the epistemically illuminated region aspect. But for both of those reasons, because of the complexity of the space and our lack of knowledge about other forms of life that are possible, I don't agree that we have the ability to know whether our universe is in a sort of typical or expected situation with respect to how much of the surrounding parameter space is not life permitting. In my opinion, the evidence isn't there's nowhere sufficient evidence to say that that's not the case, and that's one of the reasons I don't find the argument convincing.
Well, it's always unlikely. The more atypical something is, the less likely it is. So it's always if your argument relies on it being very untypical, then that hypothesis is itself the fact that it looks so atypical is strong evidence against the hypothesis that over the entire space is there's lots and lots of bullseyes, so to speak, because you would expect ours to be closer. You wouldn't expect it to be absolutely typical, but it would be close to typical. And I think that you don't have to worry about the complex. Yeah, I don't think you have to worry about the complexity of the space because the integration works no matter how many dimensions you have. The integration will do, if you did just the dx or dy, you would brings you down one dimension, then you do, dz brings you down another, but the same process occurs.
Well, if I have a 30-dimensional space, and I need to know in each combination of those dimensions whether that combination of parameters is life permitting or not, and then I need to do the integration over that, and then say whether they're resulting in the epistemically illuminated region, whether the resulting sort of hypervolume is the amount of life permitting constants spaces within that region is expected or not relative to the whole space. That's what I think you would need to do in order for this argument to be convincing, and I don't think we're even close to being able to do that.
Well, you'd always expect the further the epistemically illuminated, and there's no reason under atheism or naturalism you would expect the epistemic illuminated region to be super atypical in this regard.
Yes, yeah, exactly. That's what I'm saying.
Okay, but if there's no reason to expect that, and it is, and then you're hypothesizing, there's no reason to expect it to be atypical. And so then it strongly confirms that it says there's no reason to expect atypical. And if it is atypical, that's very improbable. The hypothesis that it is atypical is strongly disconfirmed, which means it strongly confirms the hypothesis that it's typical. And if it's typical, then that gives you reason to expect over the entire space. This is the epistemically illuminated region is a typical region. You only would not be able to draw that conclusion if you thought there was some bias that occurred when you epistemically selected it so that it would make it look like the life permitting region is really, really small, but you're not getting that.
Well, I've argued one reason for that is because I think that we're biased based on defining life and looking for the conditions of life based on life that we know, which is going to be biased towards what actually exists. And the other reason I've said is because that we tend to look at modifying one or two parameters at a time, and then even then only on certain structures that will form. Whereas if the space is very complex,
go ahead.
If the space is very complicated, that doesn't tell you about whether there are local areas where there is no other bullseyes. That doesn't necessarily tell you much about whether in the space as a whole, even the local epistemically hypervolume around where we are, that doesn't tell you about the total hypervolume of that region, which is, I think, again, what's relevant, because the claim is that, again, my claim would be that what we would expect under which I think you agree with, what we would expect under naturalism is that the proportion of constant possibilities surrounding within the epistemically illuminated region of the actual universe that we have should be similar, reasonably similar to what it is in the overall space. That we don't expect ourselves to be dramatically different or special in some way. And so my claim is that we don't have enough knowledge about what that space looks like, even locally, because of partly because of the dimensionality problem, partly because of the exotic life problem, to make the claim that it is substantially different.
So it's going, but the dimensionality problem is already taken care of with the epistemically illuminated idea. So your exotic life problem, now there you're claiming there's a sort of bias, because of course we're going to be biased towards our form of life, the requirements. So if I were making the argument about carbon-based life, or I required a planet with all the particular conditions of Earth and saying, wow, isn't that unlikely? Then you would be, and this particular form, if I found that this particular DNA that humans have in the particular form, wow, that's super unlikely. I mean, of all the possible forms, and if I was identifying life as that, then your argument would work. But I'm doing something very general, just the general notion of embodied conscious agents in a very minimal condition that matter stick together. That's a pretty minimal condition.
I agree, but we don't know the conditions under which that will be fulfilled. All we know is the conditions under which we won't have the type of matter sticking together that we currently have. And I think
we do know the conditions. We do know the conditions for the epistemically. The epistemically illuminated region is that area of parameter space, whether we can determine whether that condition is met or not. And in that region, it's a very, very small region. And like I said, the idea that it's near typical, as you more and more you assume it's further from typicality with no bias, because there's no bias in just looking at the parameters. There's no bias.
I think there is bias. I think that there's almost certainly huge bias, because precisely what defines what is epistemically illuminable is our cognitive capabilities and our ability to infer based on the things that we know. That's obviously biased towards things that we understand, and away from things that we don't understand or that are dramatically different.
No, it's not life that we don't understand. It's just this simple condition of...
Yes, but that's the same idea.
It's the simple condition of matter coming together. So if we could agree, so we got to separate these questions. If we could agree that matter sticking together is, let's suppose we just agreed on this, just for the sake of argument, that matter sticking together would be a necessary condition for life. Then how does that introduce a bias to the relative size of the life permitting region to the epistemically life permitting part of the life permitting region that we can determine, the life permitting subregion, the size of the life permitting subregion of the epistemically illuminated region to the entire illuminated region. How does that introduce a bias?
It introduces a bias because of what, in my opinion, I got to be careful here. I think there's reason to suspect that it's biased. I'm not saying we know that it's biased. Let me be clear there, because I think the answer is we don't know. But why would I expect it, or why is it reasonable to think it introduces a bias? For the same reason that I mentioned before about the complexity of the underlying space. So let's take, again, many examples from chemistry or biology where we have complex systems composed of multiple parts. And if we think of these different components like bond angles and things like that as analogous to the parameters in the standard model, and we can imagine varying each of them singularly, you pull apart one bond or twist it in one angle, and what you'll get is a very high energy structure. And then so if you do this individually, or maybe even like two of them for these parameters, and in each instance, you're likely to say, the resulting structure won't be stable. And so you conclude in the epistemically illuminated region of this molecule or whatever, or this protein, we can tell that tiny variations would render it impossible to exist. And therefore, we might conclude that from the epistemically illuminated space of this structure, then its existence is highly sensitive to very small perturbations in any of the parameters. But what we would miss is that, at least for many of these structures, there are other possible conformations. It's just that they're removed in the overall space, because the space here, I'm talking about like bond angles and distances and things, is not simply connected. And we know that partly because we know a bit about how like biochemistry and things like that works. We know that if you just looked at sort of along individual axes, you'll get a biased sense sense of the overall space. The overall space could actually have many conformations that are possible, that are stable to have like functionally similar results. And I would expect the parameter space to look similarly for the existence of life.
Well, there might be many other spaces that would get functionality, but when they suffer from the similar sort of problem, very small perturbations, they wouldn't work anymore. I mean, if you find that, let's suppose you find
in individual small perturbations. That was the point of like the
but then other ones
example
would
I was
have.
giving.
So most of the parameter space would still not be allowed for life, because
But that doesn't follow. That's exactly what I'm saying. Just because a certain structure or system is sensitive to individual perturbations on one axis doesn't mean that the overall space is sensitive to those perturbations if you make multiple changes at once. If the space is not simply connected, then that doesn't follow.
Of the right changes, then you get to another little small point surrounded by non-functional points.
Well, yeah, but that's the thing. It wouldn't be this simple, but it's quite possible for if you imagine a large area filled with hills and valleys, right? On each hill, it's surrounded by a valley, and if you just looked around, you'd say, it's a valley all around here. I must be on the highest spot on the plains or on this area. But in fact, it could be that the space is equally covered by hills and valleys if they're just interspersed amongst each other. That's sort of an example of what I'm thinking of. Obviously, that's a two-dimensional example, which underestimates the overall complexity. But that's exactly the sense in which I would expect the epistemically illuminated region to be biased, because of the way that we're thinking about it and what we can observe versus what we can't observe.
Yeah, I don't see how what we can and cannot observe is going to do it. But even
that defines the epistemically illuminated region. If we can't observe something or infer reasonably about it, then that's systematic with respect to the conditions of life, then there will be a bias on the epistemically illuminated region.
Not a bias of the proportion of life permitting values.
Yes, there will be.
Why?
In just the way that I explained it.
I didn't quite get the way you explained it.
Okay, so let's use the hill example. If I'm standing on a hill and I'm surrounded by a valley, if I can only see a certain distance away, I might infer, based on the epistemically illuminated distance, I'm on the highest spot in this whole region, even distances that I can't see.
Well, no, but that's not what I'm inferring. I'm at the highest spot, the only one in the entire dartboard. I'm not inferring that. I'm just inferring that most of...
I was simplifying the analogy to get the point, right? It doesn't matter that it's the highest spot. I'm the highest spot for a long distance around, at least.
If you randomly picked a place that was in your configuration space, if you randomly picked a point where the configurations allowed for life, if you randomly picked up one, you wouldn't expect that one to be and the space around it, the points of possible variations, you wouldn't expect that one to be one in which it was way different from any of the others. You expect
any of the other points in
any other points that allowed for life in your space.
Well, no, yes, that's my claim, and that's what the analogy of the hills in the large area is supposed to be showing. The hill is analogous to a point. Sorry, Matthew, do you want to? I don't know if you want to interrupt at this
point.
No,
I wanted to say one thing, just apart from this question, in the actual physics of it, most of the parameters in the standard model, for instance, have little to do with the existence of life anyhow. I mean, you have to, and when they do, like the mass of the bottom quark or the mass of the tau lepton, they decay away so rapidly. They really have if you change those masses, the tau lepton, for instance, has a mass is a second generation lepton. Electron's the first generation. It has a mass of 1.777 GeV. It has a lifetime of 2.9 times 10 to the minus 13 seconds. That means 0.39 trillionths of a second. It can only be produced in high energy accelerators, colliders, and it decays away before it can have any effect on life. So huge variation of that would not affect life at all. You would have to vary it all the way to, if it got too large, it would cause the Higgs field to become unstable. So most of those, the masses of the second and third generation quarks hardly affect life. Like in neutrino oscillations, the angles of the neutrino oscillations. They affect the amplitude of the oscillations, but since neutrinos don't bind together or anything, they don't affect life. They just don't have any effect. So there's only a relatively few that have effect on life, those affecting how matter binds together. And those would be the masses of the first generation quarks and leptons, mass of the electron, mass of the up quark, mass of the down quark. And so, and then the neutrinos do, if they're too heavy, they have cosmological effects. And the rest of it is, and then you have the strength of the forces, nuclear force and electromagnetism and gravity. But it's a very limited number. And we pretty much do know what's going to happen if you change, if you decrease the strong nuclear force too much, you're just not going to have protons binding together.
Yeah, well, if I can just briefly respond to that, maybe before Matthew changes us on topic, I agree that we know what will happen if you change, say, the strength of the strong force with respect to the existence of protons or they're binding together. That's not my claim. My claim is, and in fact, I would say that the fact that most of what gives us life is only a small number of the parameters and particles of the standard model, up and down quark, electron, for the most part, and electron neutrino a bit as well. That to me just means that there's a huge, vast range of possibilities of what might possibly exist when you change many of the parameters. There's no reason why these types of interactions couldn't be stronger or couldn't be longer lasting, again, if you change enough of the parameters in that space. And I don't think we have a great ability to really know what.
Well, I don't think you could, if you decrease the strong force, what would make it things stronger?
Well, I'm not going to tell you what combinations of parameters would give rise to what types of possibilities for life. I don't think anyone knows that. And so I'm not going to say here.
No, I do think you know that. I do think we know that. We do know.
We know that quarks, we know, for example, the protons wouldn't form. That doesn't mean that no complex embodied life could form. That's a huge extrapolation. That's my.
Well, we know, we just have, like I said, if you just have protons all spread apart, or you don't have higher level elements, you just don't. It's very, very implausible to think you have any kind of complex structures that could.
But that was the assumption. The assumption was if we only have that, but we don't know what we would have. We know that we wouldn't have what we have now. We don't know what we would have, especially when we consider, again, all of the parameters that can vary and all of the possible structures. But this is the point that I've already made before. So I
don't agree with that. I think we actually can.
Well, I don't expect that,
because there's simple enough cases. There's simple enough cases. Just like I said, if you increase the cosmological constant enough, you just wouldn't have.
I already responded
planets.
to that argument.
Yeah, but you didn't.
Matthew, maybe we can move in a different direction. Sorry, feel free to finish off that sentence, but I just encourage.
We can move in a different direction.
Yeah. I mean, So, I mean, I guess I have one question about the sort of the Hill case, because I think maybe that case seems good for Robin's point, so imagine we're trying to figure out, there's some hypothesis where some agent built a platform to raise me up, above the surrounding area, right? So that's the hypothesis, that someone built a platform for me to raise me above the surrounding area. And I look around for the nearest 1 million miles and I see I'm elevated above all that other area. Even though there might be many higher areas in the other places, there's still evidence for the platform hypothesis, because it's so unlikely that in that illuminated region that I can see that I would be at the highest point on that. So I guess, what do you make of that analogy? Sorry, I maybe I shouldn't jump in as the moderator, but
no, that's fine. I don't mind. And sorry, I didn't mean to cut you off, Robin. I just wanted to make.
Oh, sure no, that's okay. I mean, I think we hashed this out. I'm glad that Matthew's. Sometimes you just need a third point of view.
That was why I suggested that. Well, okay, so regarding the sort of platform example, well, I think that is supposed to be an analogy to illustrate the point. It shouldn't be taken too literally. So obviously, if you were on a platform and you could see 1 million miles in any direction, what we know about geography and so forth, that would be pretty reasonable to think that you're on the highest spot, in a very large area. The idea is that the idea is simply to indicate that the local properties of a space do not necessarily tell you anything about the global properties of that space. And the example of being on a hill and only seeing, the valley surrounding you, is, I think, a simple example where you can see that from your point of view, it looks like you're on the highest point, at least as far as you can see, right? But in fact, it could be the case that you are on the equally highest point to, like, I guess if they're kind of a plateau hill, to half of the space or even more in the overall area. It just depends entirely on the exact topology, right? It's that's the only point it's supposed to illustrate.
Right, but then I think Robin's point goes through, which is that so if you have a hypothesis, right? So so there are the constants are fragile in the sense that if you change them slightly, no interesting structures would arise. And so you're saying, well, maybe in the other bits of like the possible values, maybe that there are these large values where see entire islands of possible values where where they could give rise to life. But of course, if they are that way, then it's very unlikely that we're in these very sparse regions that are where if you tweak the values, they give rise to life, right? So if you find yourself at the highest point in the surrounding area, that gives you evidence for the platform hypothesis, because even though it might not be that you're at an unusually high point, on the hypothesis that there are all these higher points elsewhere, it's very unlikely that you'd happen to be on that point. But
the density of points,
it depends on the properties of the space, right? If you have a region, I mean, this is purely a sort of geometrical argument, right? So I don't think this should be controversial. So if you have, imagine you have a space, and I randomly, I split it up into hexagons, right? And I raise up half of the hexagons so that each of the raised hexagons is surrounded by a lowered hexagon. And now imagine I'm standing on one of the high hexagons and I can only see the surrounding hexagons. By definition, half of that space is high and half is low. And yet I can, on any hexagon, raised one, I can only see low hexagons. That's the analogy. So half of the space is high. So the probability that I would be on a high point is 50%. And yet I can only see, again, I'm postulating that you can only see the surrounding hexagons. I can only see low hexagons. Now,
but is the high where you're on the high hexagon, is that just a really little thin top that you're on? And then as you move out, and yeah, you only see lower hexagons, but is the lower hexagon region much larger in volume, or an area if you're in 2 dimensions, than the high hexagon region where you're at?
Well, that obviously would be relevant to whether this carries to the fine-tuning case. But in that simple example, I was just stipulating that the whole flat area is covered by hexagons of the same size, and then we raise up half of them separated equally. The area would be the same.
Yeah, but that's the whole issue. If the area was way more, then it would be, even if you had a high hexagon region, it'd be very unlikely you would be at that tip versus in one of the lower regions. So the argument still goes through about fine tuning.
I accept that it's obviously more complicated than that simple hexagon example. I was just trying to illustrate the point as to what the difference between local and global properties of a space is. But I don't think we need to rehash that point.
Yeah.
Further.
Yeah. I guess, I mean, the only other point is that I was thinking of is I think maybe, so James, your point, you think maybe life could arise under very different conditions if we tweak the physics. So maybe if you had a stronger or weaker,
as far as we know.
Yeah, right. But I think even if as long as you think that's like suppose you think there's a 10% chance that that's right, or sorry, a 90% chance that that's right. That still means in the 10. So if that's wrong and theism's true, then it's very likely that we would get our particular cosmological constant. Well, if that's right, we could get any of the cosmological constants. So as long as you're at all uncertain about the point, then I think it'll make it so that we get very strong evidence that at least for the conjunction of theism and it not being possible to have these other kinds of carbon-based life, because all you need is that a cosmological constant like ours is not terribly unlikely on theism, right? Because it's so unlikely on naturalism, even on that hypothesis. And so as long as it's not terribly unlikely on theism, then I think the point can go through.
That this would be the form of life that God would, if God was creating an embodied conscious agent, that this is the form that God would create, or that would be stands above the others. Even if that was only a 10% probability that this was a superior form, then that would only reduce the probability that God would do it. you don't know by a factor of 10, but that would still be far larger probability than it being in this teeny region of parameter space.
Right. So like an analogy might be like, suppose John, you think you sort of heard a rumor that his favorite number is 1,800,558. And so you think that has, maybe a sizable prior probability. And then you see that he wrote down some number on a piece of paper, and then you see that it's exactly that number. Even though you weren't initially very confident if that was the only number that he was likely to write down, because there are so many numbers that he could write down. Now you get a big evidence for that he wrote that down, that he has a preference towards writing that down. And so similarly with God, you get evidence that God has a preference for creating carbon-based life forms, and not necessarily carbon-based life forms, but you get evidence for the conjunction of for a theory on which God would want this cosmological constant, which that theory isn't terribly improbable, right? Because it might be that this is the only way to get life.
So here's another analogy I kind of thought of on this counter analogy. So, there's many kinds of houses people can build. And so you come in and see a house and you say, oh, it wasn't really designed at all, I'm just throwing together. Because why was this house built? There could be all these other kinds of different structures. But what we're comparing this to, what the proper comparison to is not all the other possibilities an architect could put together or a designer could put together. It's the possibilities of this place being really poorly designed or not designed, randomly put together. There's all the bricks or the beams, they could all be in random locations. And so we say, of course it was designed, just like we would, if we found a car on Mars, we would say, of course it was designed, it just didn't precipitate out. We might say, well, why there's all these other configurations of metals that would have led to a workable car. Well, so what? Because the proper comparison class is not all the other possible cars, it's all the other possibilities of these elements that wouldn't lead to cars.
Yeah, well, I'm just trying to think about the car analogy here. I don't like analogies to design from artifacts because we sort of have a lot of background knowledge about how those come to be, which I feel like bias the way we think about them. But the point is that it seems to me that the fundamental question, which actually I think Luke Barnes sort of appeals to when in his article, A Reasonable Little Question, although I don't want to be saying he'd endorse my argument because he isn't. But the point is that the fundamental question is something like, we find ourselves in a universe that supports life, the existence of embodied life, right? And furthermore, at least when we vary some of the constants of nature, we find that the resulting universes would not be conducive to life as we know it, right? So we're all in agreement with that point. And so the question then is, from my point of view, what is the best? I know you don't formulate it as an explanator, as a best explanation, but allow me to formulate it in these terms just for the sake of argument here. What is the best explanation for this state of affairs? Should we think that we were designed, that God created the universe and us in this way for some reason? Or should we infer a multiverse? Or should we infer that it was essentially just chance? All right. Now, in order for the chance, the single universe naturalism argument, as you called it, to go forward, you have to come up with an explanation as to how it's at least not, ridiculously unlikely that we could find ourselves in a universe with these properties relative to sort of the other set of possibilities. And that's where I see that the other set of possibilities does become relevant, because you can only assess chance relative to the other possibilities. So I don't want to say claim, because I don't think we know, but my speculation or my belief would be that I haven't said that very well. It is my opinion that the evidence is consistent with the universe that we find ourselves in being not dramatically unlikely relative to the other possibilities that we might consider that it could be. That is that, well, yes, it may be the case that many types of constants wouldn't support life, but many types would, and in many different possible combinations of many different universes with combinations of constants that we could find ourselves in, we would likewise see surrounding areas where the parameters wouldn't be suitable for life. So the idea is, again, that the explanation of this phenomena, the universe that we found ourselves in, and the fine-tuning evidence is potentially just that this isn't that atypical. And so the point is, I'm not saying you will agree with that, but the point is simply that the point is simply that we do need to consider the other possibilities of life when we're making that assessment as to how typical it is.
Yeah, well, if we assume that there's the typicality of life permitting areas, but there's also the issue of the typicality of finding yourself in what I guess Matthew called a fragile region, where you're surrounded by large areas of parameter space that don't allow life. And I'm saying that either you have to claim that this is typical, it's typical that life permitting regions are very rare, in which case you're conceding the fine-tuning point, or you have to say it's typical. It's typical that it's not. You would have a fine-tuning problem that we find ourselves in a fragile region, because if it's typical for most regions not to be fragile, then it's very surprising we find ourselves in a fragile region.
Well, that was my argument with respect to the analogy of the hexagons in the valley and the angles and bond lengths and so forth.
But I
think it is typical, or at least it's plausible to think that it would be typical that life would be fragile in this sense.
Well, if it is typical, then add all the volumes. Take the volume surrounding the one region. Take the volume surrounding this region and add all the volumes together for the life permitting areas. And since the surrounding region is much larger, and add all the surrounding regions up, you're going to have to get much, much larger surround regions with no life than the total volume of regions with life.
Well, that's not true if the space isn't simply connected, if it's a complex topology.
It would still be
if you
true.
have an interscattering of many areas that are. I mean, this is the hexagons in the field example again.
True. I think it mathematically would be true that if you just add the volumes up, if the volume I wouldn't say just around the volume that we're in plus the volume the others are in, but then there's a volume no one can see no matter where you are. Okay. But then all the seeable volumes would be, if it's typical, all the seeable volumes would be much larger. And then you would have the unseeable volumes that no one could see. But
maybe we've beat this topic to death, or refrain from saying anything I have to say about it.
I'd like to talk a little bit about, in the time we have left, a little bit about like God and the design hypothesis specifically, if that's okay. Because that's the other aspect of it. We've sort of been talking about the fine-tuning aspect specifically, and epistemically illuminated space and the possibility of other forms of life and so forth. But I'm actually just as much interested in the question about whether God, like a designer hypothesis, is a good explanation of fine-tuning, or has a high likelihood with respect to fine-tuning. I guess is the way you framed it. But I mean, there's a lot we could say here, and I don't know how much progress we can make in the time. But I guess one question I have is why God is in the business of fine-tuning parameters when he is the one who created the laws. That seems a little bit. It sounds odd to talk about it as if God is constrained by the laws of nature that he created.
Well, I think God creates the laws and the parameters at the same time.
Yeah.
It's only a conceptual distinction we make. So
right.
God, it's over the conceptual space. I think these probability arguments are done over conceptual space because it's an epistemic probability. So it's all the things the space of possible we can conceive of, the possibilities, and then God could create this same mathematical form with a different, like of Newton's law, with a different value of g. So and since we can't, since it's really hard to know what happens when you completely, in other radically different law structures, it's what I do is I hold the if I'm going to get any quantitative estimate, I need to hold the law structure, the mathematical forms constant, and conceptually consider the others distinct. So it's really that's all that's being done. It's not that God first creates the mathematical form and then the constant, just the constants.
Well, it's just that the form of the argument seems to be that in order for life to exist, the constants have to have certain values, and if they didn't have certain values, then life wouldn't be possible, right?
So given, no, it's really given, and my main big article
Sorry.
on this, I flashed it out as given as the background information is given the law structure.
Right.
Then so because I don't think we can really access quantitatively at all how much of all the space. There's no way of quantifying changing of law structures and all the ramifications of that. There's really is beyond our ken.
Right. Well, I mean, I certainly agree with that. I think that's even harder than looking at the constants, which is hard enough. But that raises a question to me as to whether this exercise is even really meaningful, because if the vast majority of the possible variation that we can conceive of is completely inaccessible, and then we're just going to say, well, we'll condition on the laws that we know. Why exactly do we decide to condition on that? I mean, we could just as well condition on the fact that we know that life exists, and then the whole argument becomes meaningless.
No, we don't.
Observation.
You always you only can throw into your background what you have no reason to think is relevant, or you can't determine a probability on. So that's like the dartboard, the epistemically illuminated region. If we already know the dart's going to go into that, it's going to go somewhere. Now, if the fact that it's going into the epistemic, the illuminated region was relevant, that was much more likely under the random hypothesis than the dart thrower. Then you couldn't just include that in the background. So what you always do is you can. It's fair. My claim is to include in the background any information that doesn't favor the other side. We at least don't know.
What is the other side?
The other side would be, in the case of the dartboard analogy, the other side is the hypothesis that the dart was randomly thrown, and in this case, it would be the naturalist hypothesis. So something that was unlikely, more unlikely under theism than naturalism. So, like, you could throw, if you knew the exact position of, which would be actually impossible, of some set of atoms, let's say, well, you would have zero probability on both hypotheses of those exact positions. Okay. So even if you knew that, you put that all in the background information. You don't try to put that as the part of your evidence, because then you get zero probabilities on each, because the chance of God creating that exact position of those atoms is zero, just like
I'm not talking about an exact combination. Yeah, obviously, if you're working continuous space, that's true. But what I'm saying is, in order for the fine-tuning argument to work as an argument, at least as the way you've articulated it, you need to take the laws as part of our background evidence, and that seems to me a bit arbitrary, because we can conceptually imagine varying them just as much as we can conceptually imagine varying the constants in those laws.
But we can't determine anything. We can't determine what would happen, and therefore, that all goes into the epistemically illuminate. It doesn't count as evidence for anything. It's like we can't determine in think the gun example, those scratch marks on the gun. We can't determine. They may be relevant to whether the person committed the murder or not, but if we have no reason to think they're relevant, we can just leave them as information in the background and not vary them. We don't vary.
But in that case, if there was sufficient, this is not a minor detail like scratch marks on the gun. This is kind of the whole deal, right? Which is the forms of the equations that govern our universe. That's not a minor detail. If if unknowns of that magnitude existed in any criminal trial, there's no way that a conviction could be established, because there'd always be reasonable doubt about literally anything that's being discussed. So in the similar case, it seems to me making it's just a huge it's a huge problem with the argument that it just has nothing to say about what would happen if we varied the equations. We should be very skeptical about any of the inferences made, because there's so much that we don't know there.
There's no problem in Bayesian reasoning if you actually can get a probability. Granting you can get a probability of given you put the laws into the background, and you fixed whatever other constants you can't determine what's going to happen. You put those into the background, then you get the evidence is the life permitting values of those constants conditioned on that background. Then that evidence does end up raising the probability of theism over
I agree with that.
and that just follows within the Bayesian framework. So
I completely agree, but
where have things gone wrong?
Oh, nothing's gone wrong. It's just we've done a calculation. You can put anything in your priors that you like, and then do an update of likelihoods with other things that you haven't put in your priors. The question is, what relevance does this have to anything? And I don't know that it does have much relevance to anything if you just start putting some things in your priors and others not. What bearing does that have on?
Well, you could imagine
which is the probability that God exists.
You could imagine somebody not knowing that, and how they would update.
Yeah, that's what it would tell you. But we're not in that position, so I don't know how that's informative. We are in the position of knowing that life exists, at least given our laws, but then we don't know what laws, what other laws could be.
That is just what that tells you is how things confirm relative to the background. So I do think that's relevant.
Yeah, relative to that background, assuming that background, but that's precisely the point that I'm making. That's not our actual background. That's just a hypothetical background that we've invented for this purpose.
Well, we do have that as our actual. I mean, we actually have the whole thing as our actual background. So that goes into the problem of old evidence, if you want to press on that problem.
Well, that's essentially the point.
So what can go in the old evidence problem? And there, I in the article I don't want to go into it tonight, but it's developing. You have to develop idea of probability and look at cases like, I look at the confirmation of atomic theory by Avogadro's number. What's in the background is a whole bunch of things about physics, and then what's in the evidential basis is that these different methods all led to the same value of Avogadro's number. So I look at cases like that. And how you get confirmation in those cases. So that is a more difficult question to address. You have to develop an account of epistemic probability.
Yeah, well, I agree, and I've Matthew and I've discussed this.
So if it just pushes into that question, that's a different question, and so then we need to have some time to talk about.
Yeah, sure.
That can you conditionalize? Can you use as evidence things you already, as rational human beings, know? And I think you can, but that's another argument.
Yeah, that's fair. That's a complicated story. I have another question that I wanted to ask. Maybe this will be the last sort of strand, but and it relates to because I'm pretty skeptical about our ability to.
Sorry, James. Just before you ask that, Robin and James, like, how much longer do you want this to go?
Maybe 10 more minutes. It's getting late back where I'm.
Yeah, that's what I was thinking as well. That's why I wanted to make this my last question.
We could do this again because we only really did one question, and I found it stimulating. I'd like to see more on your hexagonal example.
Okay, well,
maybe I'm having a hard time conceptualizing why you say that. It could be atypical and yet not atypical and not atypical, likely atypical over the whole space.
Yeah, well, we could talk about that more another time, perhaps. But if I can ask this last question about the gods, what was I saying here? Yeah, so I have I'm pretty skeptical about our ability to make inferences about what God would or would not be likely to do or to create, absent, particular theological assumptions there. But here I want to ask specifically about why God might have a reason to create embodied life, because that's one of the things that's puzzled me a bit. Well, actually, there's sort of two aspects to this. Feel free to just touch on one of them if you don't have enough time. One is why God wants to create embodied life specifically, as opposed to disembodied life. And the second one is why God creates embodied life, or has a reason to create embodied life in a universe with constants that support that life. Presumably, God would be able to create life in any embodied life in any universe, regardless of its constants, because, I mean, if there's no logical inconsistency, then he would be able to do that. So one is the relationship between laws and the embodied life, and the other is just embodied life at all. Feel free to tackle either of those. Or
well, I actually think, you know, the best answer is stuff for the second one. What I'm already working on is that the universe is fine-tuned for scientific discovery.
Right.
And then beyond that is that it's actually what I call the discoverability signaling hypothesis. The constants are set actually to signal that it's fine-tuned for scientific discovery. So then God's interested in us coming through science to know that there is such a being, or having good reasons to believe that. And so even that's a big if, God could create a kind of consistent law-governed universe. Maybe there's reasons for creating a law-governed universe, and one just that has some depth to it, instead of just kind of, you know, like electrons and love kind of universe, that maybe God has, you know, there's a paper like that.
Yes. Well, what do you think about that paper? Well, not the
Well,
paper
I haven't thought about it in detail, but I think the easy answer is that it's a couple answers. One, maybe God does create that kind of universe, but as long as God has a reason also to create this kind of universe, just like you have a reason to create one kind of car and a motorcycle. So it doesn't have to be this one's better than that one. God might be multiple different universes exemplifying different goods. That's the first point. The second point is there is something on if discoverability is important, then there's a good that can be realized. If it's a good, then there's a good that can be realized by fine-tuning. And if I'm right about that, then it should turn out that, you know, this other feature of the constants, and I think my work is now showing that that's actually the case, but it hasn't been completely published yet, that the universe is fine-tuned for scientific discovery. And I didn't mention, I was just staying with the anthropic fine-tuning argument, and that one avoids the whole background, the old evidence problem. So that's another reason maybe God wants us to find out through science the existence of God. And maybe even though God could by a continual miracle do this, it doesn't seem like such a thing would be a law-governed universe with laws of any kind of depth. And there's a value in God's not constantly intervening or being too evident, God's existence being too evident, that allows room for free choice. So there's those kind of reasons that could be given. And all I require for, you know, divine psychology is that we can glimpse a good that would be realized. That makes this kind of universe, an embodied conscious agent existing universe, stand out among all the other possibilities. And that's all I think is required. Stand out in a positive way. That's all that's required for the argument to work, that its probability is then not just given by equal probability distribution as under the naturalistic single universe hypothesis.
Right. Yes, I have read you use that phrase to a glimpse of the reason why God might create something. That methodology doesn't. I mean, obviously you won't agree with this, but just interested with your perspective is that methodology doesn't seem very robust to me, because it seems that if we look at things that exist, it's not, and if we have a bit of an imagination, we can always come up with some reason why someone might want to, we may at least glimpse a reason why someone might want to create them, what some potential value that they might have. It seems to me that with enough imagination, you could come up with something like that for nearly anything that exists. Maybe not absolutely everything, but at least lots of different things. I mean, after all, in responses to problems of evil, people have come up with all sorts of things that goods that might be embodied by things that ordinarily seem pretty horrible or indifferent. So do you think that there's a potential of a lack of constraint on what we might? I don't think so. I think that
okay, beauty is one thing, but I don't even think that gives God a great motivation for creating the universe, because I think a virtual reality is beauty is tied to structure. So a virtual structure is as good, as beautiful as it being actualized, but I don't think there can be virtual good acts. And so I think good um, ties with conscious states. And I think those are the kind of reasons that would motivate um, God, who I buy a variation of Swinburne's argument that once you get God is omniscient, omnipotent, and perfectly free, which I think you can plausibly argue for from a deeper premise, then you get God is perfectly good. And then I think the good, it's at least plausible to think the good is self-motivating, thesis that goes back to Plato, that if you recognize something as good, it gives you a reason to bring it about. So people that don't do good either haven't recognized the thing as good or have a contrary motive, some contrary constraint, and God is perfectly free, doesn't have that. So then you have to, the reason has to be some good. And goods then there's the beauty, but beauties are connected with structure, and goods are connected with conscious beings and their actions. So states of conscious beings and their actions. So that really narrows down the territory, and it makes all these lifeless universes. There's not really any extra goods to be realized over a virtual set structure. I have a real lifeless universe versus um, just a virtual structure in God's mind. So I think then you can actually narrow it down to having some embodied life. Now, God might create unembodied life, and Christians do think so with angels and things like that. But all you have to have is a reason. So there could be other universes, other realities. There just has to be a reason for creating a reality that of embodied conscious agents that we can glimpse. So that's my more filled out answer.
Well, it just seems to me that we could potentially glimpse reasons for God creating any number of different types of things, depending on what our assumptions about the nature of goodness and beauty and such are. And this is one of my objections to these styles of arguments, that it seems to me that they hinge on a whole range of other assumptions about these issues.
So you think that something that's completely lifeless, you could say one of those is more good than another? Seems good attaches to consciousness.
Well, look, that's one position, right? And obviously that's going to be outside of what we can adjudicate here. But there are many people who don't think that the only things that can be good are conscious states of affairs. And so really what the question is,
okay,
what
so then
being,
yeah, well then let's you could either go there's something specially good about that. So there's a special particular reason that's greater than reasons for creating ones that don't have conscious state affairs, or make that stand out. It's a special reason for creating. That's one way of going. Or you could just add the assumption and say it's plausible. You can add to theism, you can elaborate it, as long as you don't add assumptions that are just as improbable as what you're trying to, get out of it, explaining the fine tuning. So, because then the probability, it's the probability of this, what I call elaborated theism plus this assumption. And as long as that assumption's not terribly implausible, then you're okay. It confirms that joint hypothesis. And then you can do a simple theorem to show if it confirms the joint hypothesis, it's also going to confirm the actual hypothesis.
And of course, it comes down to how many hypotheses we're adding and how plausible we assess them to be.
So we want to make sure the hypotheses we add aren't just terribly improbable. Like if you add if you say, any constraints on God's desires, or suppose you believed in a generic intelligence, that you would have no reason to create a life-permitting universe versus any other. And you could add the desire to create the life-permitting universe, but then you've kicked the improbability up. Just like you could, explain, if I won the lottery, you could say it was rigged, even though, and anybody won the lottery, you could always explain it as being rigged by saying, oh, the person, the lottery commissioner wanted to rig it in that person's favor. But that's always going to be very improbable unless that has some sort of a priori probability. So I don't think you can. It's not a free for all in doing that.
Yeah, that's fair. If God has a reason to create valuable states of affairs, doesn't that lead to some kind of prediction of modal realism or something close to that, that he would actualize any morally valuable state of affairs? Maybe, I don't know if you consider that a problem. I think some theists have
But it wouldn't be every state of affairs. So
morally valuable ones.
Yeah. So would God create every morally
Not
valuable?
literally modal realism, but does that not lead to a prediction of a much vaster creation than
Well, I do think there's a
just our
much
universe?
faster creation, so I don't have a problem with that.
Well, I'm not saying whether you have a problem with it or not. I was just asking the question.
Yeah, asking the question. So there is an issue, and there is an issue of whether each is when you get too much redundancy, is there a trade-off at that point? And I have to think more thoroughly about that. But that is a real issue. How is it every possible world that would add value? Would God? I think maybe God would have a reason to do that. Would that be the best of all possible realities in which every possible universe was realized, in which we couldn't be every possible, because some would be probably incompatible with others, but some very large compossible set of universes.
Well, and just one question I would have then is whether we would expect, whether our universe is sort of representative of, or not representative, is similar to these other creations, or whether we're sort of unusual in some way, because it would seem
everyone would be unusual in some way.
Well, so I don't know exactly how to quantify this over such a vast space, but that the point is that that's
insofar as they're different.
A different type of fine-tuning argument, that we're sort of special in divine creation.
Yeah, if they're not identical in all their properties, what's the point of doing something identical? If they're not identical, then they're going to be different in some ways. And even if they are identical, there's a kind of indexical, quantitative difference. So they're not going to be they're always going to be special. It's just the question of how important that specialness is. How much does it stand out? So, and I just say I have to think more about that issue, and what potential problems you might come in that issue, if there is problems, infinite number of universes.
I guess
I'm inclined towards this vast set of other creations. So
yeah, well, my worry is that if we did expect God to have a reason to create anything, or a vast number of things that are morally valuable, then this universe as we see it would not be expected to be representative, like relevantly similar in, let's say, moral dimensions or other aspects from the vast majority of God's creation, which raises questions as to why do we find ourselves in such a universe. Now, I'll happily acknowledge that I can't demonstrate that because I don't know how to rigorously show what the
they
space
all
would look
be
like, but
non-representative.
I worry about that question.
They would all be non-representative in some way.
Well, yeah, it's a further discussion as to what I would mean by that, but I do have that worry, but maybe that's another discussion.
I will say, seeing as this is one of the few topics that I've spent lots and lots of time thinking about.
Oh yeah, this is your thing.
Yeah. Well, James, I think you are assuming something. So there are different views of how to do this sort of anthropic reasoning, and you're assuming a view on which you assume you're sort of representative among the actually existing observers. But there are other views. Like there's one view that says basically what you do is you just count up the number of observers with your relevant evidence, and that's how you do it. That view happens to be correct. And if that's what you're doing, then I think this dissolves both of these worries, because even if you say we're not really sure what God would do, well, if God would make a vast multiverse worth of creations, then he'd just make a bunch of copies of you and of all of these good things. So in other words, that doesn't require that like our universe is special. Maybe he just creates a bunch of different universes. Right. So I think it'll depend on the exact assumptions that you have about anthropic reasoning.
Well, doesn't that position undermine the fine-tuning argument as well? If we just consider people who have our evidence, only those who exist in universes that permit their existence will have the same set of evidence as we do, right?
Well, the idea is
maybe
that
I've misunderstood that point.
But that's the weak anthropic principle objection.
Right.
Well, yeah,
No, to be clear, the thing I'm talking about is not committed to the weak anthropic principle. What it says is that if you're considering different theories, you look at the expected number of observers with your evidence on the theories, and then they get upweighted in probability proportional to the number of observers with your evidence, right? So for instance, suppose a coin gets flipped. If it comes up heads, one person gets created, and tails, 10 people get created. If I'm created on this view, I should think tails is 10 times likelier than heads. Because
so isn't theism always going to win out under that?
Well, that's the anthropic. That's an argument for theism.
I see. Well, yeah. Let's leave that for another time. Maybe.
Yeah. But
that whole area kind of stretches my brain. It's infinities. As one famous philosopher I remember said, "Infinity is the bugaboo of small minds." That was I forgot his name, but Anyhow, so. Interesting discussion.
Yeah, thanks very much. Thanks, Robin and Matthew, for inviting me. It was a good chat.
Yeah, thanks you all for coming on. I think this was very interesting. Yeah. Do either of you have any like closing words? You can like give like a 2-minute opening statement or closing statement or something if you want, or we could just wrap it up. Like,
I don't personally feel the need for that, other than I'd be happy to. I'll be happy to come back on and talk about fine-tuning for discoverability or related issues another time.
Yeah, when I get more of this developed, I'll keep you in mind to talk about that. I also do want to see. I don't really see how these larger dimensional spaces are going to do the trick on getting around my argument on the epistemically illuminated region, but maybe. Matthew, if you understand it better, maybe you can email me, or James, if you could maybe email me if you've written something on it.
No, I'll see what I can do.
I've written. There was a paper that I submitted to a few journals. It got uniformly rejected, but it was about why I don't think the argument works. But yeah.
You can send me that paper.
I think maybe I did. I'm not sure. I'll be able to send it. All right. Yeah.
But this is the paper about the epistemically illuminated region and why that should be. You get into a dilemma. Either you claim that most regions are surrounded by that, in which case you got the fine-tuning argument back again, or you claim that we're in a really rare spot in being surrounded by this, epistemically illuminated region that's much vaster than the life-permitting region. So,
I'll see if I can find something that discusses this point in more detail. It's just largely something I've been thinking about, but I think it's relevant here. Anyway, we can keep this discussion going.
Yeah.
All right.
Okay. Cool.
Thanks.
Thanks. Yeah. Thanks for coming on. Thanks for watching, everyone. Yeah. All right. Have a good night.